In this video, we'll show the trend line and dataset of the Gaussian integral using ERFC NORMSDIST and Taylor-Maclaurin SERIESSUM LINEST Polynomial Regression. We begin with the Taylor-Maclaurin series sum of the Gaussian integral, which is the summation of a times x to the power 2n plus 1, where the coefficient is a is negative 1 to the power n over factorial n times 2n plus 1, and the value n will be from 0 to infinity. So our infinity can be 16. 16 is good enough. Next, we continue with the coefficient, which is our formula, minus 1 raised to the power n, divided by, there are two parts, factorial n, factorial of n. The second part, times the quantity, that's 2n plus 1, so 2 times n plus 1. Now we can complete the Taylor-Maclaurin series sum expansion of the Gaussian integral. Our formula, series sum of the x values raised to the power 2n plus 1, where 2n plus 1 starts from 1, because n equals 0 is 1, so it starts from 1. Then n equals 1, that's 1, 3, 5, 7, 9, so the interval is 2. And the coefficient is this range. I will chart this. Insert chart. You will use scatter chart. And show the trend line. Polynomial to the 8th degree. Use the equation as label and the location at the bottom. So here we have the trend line and the polynomial to the 8th degree. We'll calculate these values, polynomial regression coefficients, using LINEST. To do that, we complete the LINEST matrix, which is array formula of the x values raised to the power 0 to 8. There. Now we can calculate LINEST data y and data x. Here you have the regression coefficients, the polynomial regression coefficient. X equals, at x to the 0, it's 0. The coefficient of x is 0.997, x squared, 0, x cubed, negative 0.313, x to the 4th, 0, x to the 5th, 0.0696, x to the 6th, 0, x to the 7, minus 6.54 times 10 to the minus 3, x to the 8, 0. Next, we calculate using the complementary error function. To do that, we will use the ERFC, our formula, starting with the ERFC, the complementary error function. And we show the equation is labeled too. So, edit chart, polynomial. The trend line is polynomial to the 8th degree. And show the equation as labeled. So here we have the equation as labeled. We'll modify this. There's a negative x, so it's negative x. Next, there is a negative 1, so minus 1 minus 1 plus ERFC. And finally, there is a square root of pi. There is square root of pi, so you factor in square root of pi. Square root of pi. And there is 0.5, so multiply again with 0.5. 0.5 times. They're all in the same trend line, and their datasets are the same. We calculate this regression coefficient using LINEST. So we expand this. We'll calculate this using LINEST. So set this aside. LINEST data y and data x. So here you have the coefficients. Let's compare the coefficients. X to the 0 is 0. Here, negative 9.424 times 10 to the minus 47. That's already 0. The coefficient of x is 0.997. Coefficient of x squared is 0. So here, the x squared is 2.22 times 10 to the minus 16. That's also 0. Coefficient of x cubed is 0, minus 0.313. And it's also minus 0.313. Coefficient of x to the fourth, 0. Here it is minus 5.07 times 10 to the minus 16. That's already 0. X to the fifth is minus 0.0696, and it's plus 0.0696 plus 0.0696. X to the 6 is 0. 0 here, that's 2.69 times 10 to the minus 16. That's already 0. And x to the 7. X to the 7 is minus 6.54 times 10 to the minus 3. Minus 6.54 times 10 to the minus 3. X to the 8. 0. And this is minus 3.88 times 10 to the minus 17. That's already 0. So we continue with the NORMSDIST. So the NORMSDIST will be, let's start with the NORMSDIST. Array formula NORMSDIST of the x values. And multiply by square root of 2. And we show the equation here as labeled. It's not showing, so edit chart. We change this to green and show the equation as labeled. Polynomial to the 8th degree. And show this as labeled. So we have the trend line of the NORMSDIST. Let's modify. We add minus 0.5. So minus 0.5 plus. The next is multiply by square root of pi. So times square root of pi. They're all in the same, the datasets are all the same, and they're all in the same trend line. Their polynomials are also the same. Let's calculate the regression coefficients. using LINEST, data y, and data x. So here you have the polynomial regression coefficient. So let's compare x to the 0, 0. This one is already 0. The coefficient of x is 0.997. The coefficient of x squared is 0. This is already 0. The x squared here, 2.22 times 10 to the minus 16, that's already 0. X cubed, that's minus 0.313, minus 0.313, minus 0.313. X to the fourth, 0. Here, minus 5.07 times 10 to the minus 16, that's 0. X to the 6, 0.696, 0.0696, 0.0696. X to the 6, 0. And it's also 0. This one is 2.69 times 10 to the minus 16, that's already 0. X to the 7th, 6.54, negative 6.54 times 10 to the minus 3, negative 6.54 times 10 to the minus 3, negative 6.54 times 10 to the minus 3. And the x to the 8th, that's 0. 0. This is 0. Negative 3.88 times 10 to the minus 17. This completes the use of complementary error function, ERFC, and NORMSDIST, and the Taylor-Maclaurin SERIESSUM LINEST Polynomial Regression to generate the trend line and the trend line polynomial of the Gaussian integral.